As you said, my name is Mitchell Shiell. I'm from the Ontario Institute for Cancer Research, and I'm excited to be here to talk about a project that we've been passionately working on called Prelude. And the title of the talk, as mentioned, Toolkit for Small Teams with Big Data Problems. So the kind of core antithesis here is addressing small teams with these big data problems with the software that we have. So who are we? Software engineering team at OICR, we specialize in building data platforms, which essentially help researchers collect, manage, and share large data sets. We've worked with cancer genomics. We work with a lot of tabular data. We've also worked with viral data, wastewater data, and we have a lot of experience doing this. And being a engineering team with a bunch of projects on hand, we try to develop a small portion of our development effort whenever we build these platforms into feeding back into these open source reusable tools, making us more efficient. That effort and the combined experience of building these data platforms has culminated into Overture, which is a suite of modular software microservices, each with narrow responsibilities that combines together to build out these data platforms that help researchers collect, organize, and share their data. So if you actually take a look at the kind of core user groups in terms of how they interact with the platform, you have data submitters that want to submit data against a validated data model. You have the data administrators who define that data model. They also deploy the resource, manage and maintain it. And then you have the data consumers, which are your researchers that bring the questions to the data. They want to take data that can answer the questions and proceed with further analysis. If you actually look at the platform itself, a pretty simple, straightforward tabular search interface where you have a fastest search on the left-hand side, and you have a data table in the middle. You can build out specific subsets of data that you're interested in. And then if you would like to download the tabular data, you have the download in the top right over there. And you can also download the associated file data if that's what the platform hosts. So the main focus of this presentation is going to be central to the administrators, so the people that are deploying and managing these platforms. Now, for most of history, that's been us, the software engineering group at OICR, and we're a highly specialized group. We have DevOps, IT specialists, we have a lot of software developers, and we have a small team of informaticians. And we've been able to deploy these with relative ease and been able to efficiently build out data platforms because of this. But our secondary aim is to develop these for broad use, not just for within our institute, but for beyond our four walls. And when we look at the smaller teams with big data problems, which now exist quite a bit as data generation has become so commonplace, we typically think of these as teams of 3, an IT specialist, or one of skilled software developers. The reality of this is it usually actually ends up coming down to one very frustrated researcher that is trying to pick up all of these skills at once. And it's just the reality of the funding models that are in academia, and typically have one first based on the collaborations we've had within the institute and beyond. They might want to share a large data set for a publication. They might want to host an internal data hub in their labs. Data and filter them quickly. We might want to be building a community for a rare or looking at pancreatic cancer of a specific subset. These are not things that typically exist as the idea is how can we get them to be able to use the platform built and developed in ways that are meaningful to their research. And it's no 7+ configuration files, and up to months, if that, of setup, troubleshooting, and tedious manual configuration. So not so the core question that we brought was how can we help researchers to build and deploy these data platforms efficiently and with fewer resources? And that's clarify that a bit later in the presentation. It takes a phased approach where every single phase the idea here is that we want to sufficiently abstract enough away such that they can build out the platform, but we don't want to abstract so much that it's now tied and it can't fit their specific niche or use case. So when we look at the phases, currently there's typically there's 4 phases. There's a getting started, sort of pre-diagnostic phase. There's the data exploration phase, tabular data management, and then file data management. And the idea here is that in every single phase, you're building out some form of base functionality that means something to the user, but you're giving them a nice guided experience, and you're not trying to get them to deploy the whole thing at once. I'm going to be focusing on phase 0 and phase 1 because I only have 18 minutes to talk. But we also have the other phases, and I'll touch on them a little bit near the end as I conclude. So what does this actually look like? So getting started at phase 0, this is all controlled by simple make commands. So you clone the repository, it's on your machine, you cd into Prelude, and then you can run make phase 0. And what we'll do is it'll do a nice diagnostic check, checks that you have Docker installed, you have the right version installed, checks that you have the right system resources available to it, and as well as having Node available. This is quite important because it can be quite frustrating when you try to run something for the fails and crashes and you don't know why. This gives you very clear indication as to what's working and what's not, and it'll give you suggestions and feedback from that simple script. I've been very intentional in terms of user experience, and on any success message, you're always going to get the next steps in terms of what you need to do to move forward with the process. To build out our web portal image, and with that built, we can then run a container locally. And so you can see here, it says, all right, we're ready now to run make phase 1. So in phase 1, we're looking at data exploration. You run make phase 1, and it's going to do automated deployment of the relevant Docker containers. In this case, it's an Elasticsearch index, it's our search API, and it's the web portal. The web portal also comes with a search UI that links with the API. You don't have to worry about much of that because it will be done for you through the Docker compose and the profile that you've just provided it. And once it runs through all of its sanity checks, it will give you a clear link in terms of where the data portal is available and where the documentation for that phase is located. And it's all internal within the resource. So when I look at the front-end UI, this is the initial front end that you'll be displayed. You have options to explore the data and look at the documentation and guides that are available. If we actually select explore the data, what you'll find is you have an empty data table. So this brings in the first question, and this is what phase 1 and the documentation that's included is all about. How can I configure the portal to display my data? This is important for phase 1 because it allows you to see platform fit in terms of your data. And we also find that decision makers and stakeholders, when you're looking at putting effort into deploying a platform like this, want to see data in the platform and what it would look like as an end result. So how do I actually get that into the portal? The researcher comes with their CSV file. So we're talking about tabular data right now, not file data. The CSV file is going to be structured as you want to see data on the front end. If I can remind you quickly, when we deployed our phase 1, we were given an Elasticsearch index. So that's going to be essentially our search engine and essentially for this case, our storage. Our search API, and we have our web portal, which hosts our UI, which we want to configure to our data. So how do we actually configure these components to our data? Well, there's 2 key configuration files. You need a mapping for Elasticsearch. This defines what the expected data structure is for the indexing. And you need a series of 4 arranger configurations, which are going to define how the table displays your values, in what order, how the facet displays your values, in what order, what's displayed by default, what's optional to display. If you're like me and you look at 5 configuration files and you're thinking of 50 CSV headers, this is a serious, tedious manual configuration that we want to offload from the user. So if you've kind of caught on, you might have seen a picture earlier on. Overture has an orchestral theme. I try to avoid using all of the names because it gets very confusing. It's like a second language. But every single service and component that we build has a sort of Overture name to it. So built into Prelude is a CLI utility that we call Composer. because it is writing your configuration files for you. It's like a composer of music where it writes the music. So given your CSV, you can use Composer to generate your mappings for you. And then you can use Composer as well to generate your arranger configurations. This saves a ton of time. It provides you a base template that you can then work off of instead of having to write tons and tons and tons of lines of JSON. So now that you have your mapping and you have your arranger configurations, you know how you want your data to be displayed, and Elasticsearch knows the expectations of your data coming in. How do we actually get the file into the front end of the portal? So like a composer writes music, the conductor plays the music. So the CLI utility that we use in Prelude is conductor. This abstracts you away from all of the API interactions. When you have a microservice architecture, you oftentimes have to deal with multiple API endpoints. We don't want that to be a burden on the user, so we essentially have a CLI wrapper utility that will do a lot of this for you. In this specific case, it's actually doing quite a bit of validation for you, making sure that this index exists, making sure that your headers match. Given the command, the upload command, it will take your CSV, and you can actually see that here. You'll point towards the index that you want to actually upload into. It will give you a nice, simple CLI UI. And on success, you'll have your data in the data table, which is lovely. So this is actually a pretty quick process to do, which in the past was a major headache when you want to set up a POC or proof of concept. Now you can do it fairly rapidly if you have experience, incredibly fast. So we talked about phase one. Overture is a complex architecture. And in phase one, we set up our data exploration. So you can see data in the table. Phase two focuses on your data dictionary management. So how do you define your data model? And then how do you build out a submission system such that you can submit data to an API endpoint and it will validate it against that data model? And then in phase three, we set up file management. So how are you actually organizing and storing and retrieving your large file data that's stored in object storage? The idea here is it's a scaffold approach. So there's no one point where the user is overwhelmed. They can focus on getting data in the table first. If it fits their use case and they want to validate that data into data model, they can proceed to the next step, only ever focusing on the configuration of two services at any given time. Now, if you're wondering, a question that we get is how do we handle access management, which is incredibly important when you think of these in a production setting. The fourth phase, which is yet to be implemented, is data access management. And that will be using Keycloak, which is a tool that we've integrated across most of our services. This is going to be incredibly important when we think about deploying to a production setting, because oftentimes we have open data and we want it to be open access, but we still need to be able to vet users and who's actually using that data. And then if you have a closed access resource, you 100% need to have authorization and authentication included. Okay, so I'm going to wrap it up. In terms of a summary, Prelude is a toolkit that aims to broadly enable teams to build and deploy platforms efficiently and with fewer resources. It's a fully documented resource with automated deployments and configuration automations, making it easier for you to start from just your data and then end up with an actual Overture platform that helps you organize and manage your data on a larger scale. Now, looking forward, in terms of some of our next steps in line on the roadmap, I kind of prioritize it from top down in terms of what's going to be probably released sooner rather than later. Deployment resources is really important. We've been deploying these for some of our internal use cases via HTTP on an internal network, as well as HTTPS on like a wider, more publicly available network. So we have a lot of configurations, and I've been slowly extracting information from our DevOps team and translating that into documentation and guides. The data dictionary viewer, there's actually a poster. Some of you may have come by and invited you to this talk. That's poster A112, presented it yesterday. So I won't be by the poster today, but if you come around lunchtime, I may be around there and we can chat. We can also chat after this talk as well too. But data dictionary viewer is going to be a very nice addition to it to help kind of make data models human readable. We've also found from a use case with our drug discovery team that the phase one, which is the index and the front end filtering, was good enough. And we felt like we were killing a fly with a sledgehammer trying to add in everything else. So we're looking at almost like a phase 1.5 where we just add in a Postgres database. So we have more persistent storage. And then we can do a similar sort of command line upload to the Postgres database and then index it over. So a simpler solution for simpler use cases. Access management is going to be a challenge, but it's a high priority. We're just waiting on one of our key data submission services. And currently in our team, we're working on visualized cohort browsers as well too that we want to add into this portal. The biggest thing that you can do for us is we have a very quick survey. It's 3 questions, and it helps us out tremendously how we target our development effort, because we have a very narrow scope in terms of what we can do for reusable efforts. So it's a 3-question survey. How large is your research team? What would you use a data platform for? And would you be interested in future feedback sessions or needs assessments? And on that, in terms of how you can get started, we have a lovely documentation site. So you can go to docs.overture.bio. And then if you look at that documentation site, what you will find is a nice link to the Prelude platform development toolkit. That will kind of give you all the information you need to get started and get going. If you'd like to schedule a meeting, do needs assessment, get a demo, we love to talk about data. These are meetings that we look forward to, believe it or not. I don't know, that probably doesn't sound weird to this audience, actually. You can do contact@overture.bio, or if you'd like, mshiell@oycr.on.ca. And then I'll lastly like to obviously thank the team that puts in all of the hard work behind the scenes. This is the Genome Informatics team at OICR, led by Melanie Courteau, and all the fine folks on the board here, creating and promoting big data tools for those advancing the knowledge and treatment of cancer. And of course, thank the funding that has gone into this. Particularly, we have a grant with NIH ITCR that allows us to do a lot of focused development effort, building out things in a reusable, more generalized and repurposable way. Okay, without further ado, I open the floor to questions. The QR code is there for the survey. Please, it takes 3 questions. It takes a couple of minutes. It helps us a lot. And I'm happy to answer the questions that you guys have.
Thanks very much, Mitchell. So have we got any questions? We've got a few minutes for questions, but I think it would be a good idea if people want to do the question, they can have 2 minutes out of the time now to maybe do the questionnaire. Any questions from the audience? Yes, please.
So you mentioned about uploading this ES3 tablet, certain storage, and you have a plan to go into persistent storage later. It's Postgres. What is the existing storage and is it horizontally scalable with like big data?
Yeah, so in terms of horizontal scalability, 100% it is, because we deal with microservices. So our DevOps team typically uses Kubernetes, and it's a quite complex setup, maybe over-engineered for the use case of a small research group. But to clarify, the simpler solution in terms of adding a Postgres database was essentially adding it here, so they can go right into here, and you don't have to worry about everything up there. We do have data dictionary management, and we have a quite robust tabular data submission UI, but it's made as a distributed data submission system. It was originally developed for the Pan-Canadian Genome Library, which is pretty much organizing data across the nation. There's functionality that's been developed in that might not serve the use case of an internal lab that just wants to put data into a database, store it, index it, and see it in a portal to filter. Yeah, no worries. We had a question over here too.
Hi. Hi, thank you for the great talk. I was wondering, you mentioned that you have user access management capabilities. And I was here wondering if you have data access management capabilities, is there any sort of functionality that you can define if your data is public or private, or if you can restrict access to this data set, these data sets?
Yeah, so there's 2 points to be made there, because the way you phrased it was like data access controls, which is sometimes thought of a different thing in terms of a portal that someone accesses, and it vets them in terms of who are you, what access do you want, and for how long, and then the data control center can respond. We've built out those systems before. We haven't done it in a reusable fashion yet, but we have a project called the Ontario Hereditary Cancer Research Network that requires a DACO portal, data access compliance portal. And we're looking at speccing it out to be a reusable development project. In terms of authorization, authentication on data sets, it's a very difficult challenge in terms of how granular can you authorize that access. With Keycloak, we can currently do it by the level of studies. So you have a specific study that is a collection of data, and then you can provide access, read, write to that data. But in terms of like individual records, that would require custom development on a developer's side because it would be highly dependent on your data.
Okay, thanks a lot. I think we should move on. So thanks a lot, Mitchell, again.
Thank you.